Now, a common formula that we work with in maths and in science, in physics, is speed equals distance divided by time. And we often think about that in terms of an SDT triangle. So on our distance time graph here, we can work out some speeds by thinking about the change in distance. So we're looking at change in distance. Now, we're used to seeing that delta there mean a change in distance, and we're going to look at change in time. And you'll see that all of a sudden, speed is equal to change in distance over change in time. You will see that that's very close to what we've been working on, and that's the gradient of the graph. Now, there's a few important points to make here about the gradient of the graph. Now, here on section A, I've got change in distance over change in time, which would be change in distance. It's gone from 0 to 3 kilometres, so that's 3 kilometres over 30 minutes, which equals 0.1. And I'd like you to think what that means. That means that many kilometres per minute. So, in every minute along, you go 0.1 kilometres per minute. Now, is that a commonly used measure? Well, no, it isn't. Let's think about what we would talk about. We would talk about kilometres per hour. Now, to get from minutes to hours, you have to times by 60. There are 60 minutes in an hour. So I'm going to times this by 60 here. And then I'm going to get 0.1 times 60. It's 6 kilometres per hour. And I would always recommend finding in kilometres per minute first, and then times by 60 to find kilometres per hour. So, and even if it takes 2.25 hours, you would do 60 plus 60 plus 15. So that's 135 minutes. That's what you would divide by. And I'm very keen at thinking about this, particularly if you're travelling in kilometres. We want kilometres per hour, but I think kilometres per minute is much easier to work it with, and then times by 60 to move on from there. Right, in section B, so I've got delta T over delta D over delta T. The change in distance, I haven't gone anywhere over 30 minutes. Well, that's 0. And whether it's kilometres per minute or kilometres per hour, 0 is 0. And that's because you haven't gone anywhere. You've stayed still. You've stayed 3 kilometres away from where you started. Usually that's talked about in terms of having a rest somewhere. And then if I finally look at section C, my change in distance, I've gone from 3 to 8, that's 5. My change in time has gone from 1 hour to 1 hour 15, so that's 15 minutes. So 5 divided by 15 is 0.3 recurring kilometres per minute. And if I want to change that to kilometres per hour, times by 60, for 60 minutes in an hour, so you go 60 times further, that will give me 20 kilometres per hour. Okay, so the steeper part of C here represents that that's going further, going faster than the shallower A here. So thinking about, again here we did kilometres per minute, times by 60 gives you kilometres per hour. And like I said, I think that's a great way of working it through, because time doesn't follow the decimal system, so you have to be uber careful. Okay?